It was a cold February day in 1924. Miners at the Milford Mine in northern Minnesota were 200 feet below the surface, looking for iron ore. Suddenly, they felt a gush of warm air coming from one of the passages. They soon heard the gurgling of water. They quickly rushed to get to the surface, climbing the 200-foot-tall ladder. The water was too fast. Only 7 miners made it out alive. 41 lost their lives that day, 90 years ago. This was the worst accident in Minnesota mining history. But even as recent as 5 years ago, down in Chile, when 33 miners were trapped for over 2 months until finally being rescued. Mining has never been and is still a very dangerous activity. Archer Robotics is here to change that. With our product, Ready Arius, we are able to work alongside miners, drastically improving mine safety. But first, let us introduce you to the team behind this product. I'm Parker, head of the team president, 12th grade.
I'm Cameron, the head of the marketing department, 9th grade.
I'm Carter, safety manager, 7th grade.
I'm Jacob, head of engineering, 9th grade.
I'm Samantha, junior engineer, 5th grade.
I'm Brandon Seaman, junior engineer, 7th grade.
Now, the most important part to developing a successful product is the team behind that product. At Archer, we take company organization very seriously. And so, even before the 6 weeks of the competition, we sat down and elected our various members. Overall, we divided our task into the engineering department and the marketing department. Engineering focusing on building, designing our robot, while marketing could focus its attention on sharing information about our team, our product, and the best organization. Now, as company president, I'm able to coordinate the two departments, making sure they're staying in communication and are working in a synchronized manner. The respective heads of engineering and marketing are able to specialize within their departments to make sure that tasks are being accomplished. Individual jobs are then also assigned to members to be sure that they are done in an organized and timely manner, such as strategy analyst, notebook coordinator, spirit manager, all important tasks that need to be done in time. Now, one of the awesome opportunities we have at Archer is a great ability to mentor. Over half of our team is 7th grade or younger, which leads to many chances for us to teach the younger members about the engineering design process and how to market a product, how to do a presentation. Lots of vital skills that they will need as they're growing older. In this way, we've got the awesome chance to reach out to the younger members of the community around us.
Now, since our team is a non-profit organization, it was helpful for us to find sponsors to help with various expenses. Fortunately, this year, most of our sponsors from previous years sponsored us again, and we also found a new sponsor, General Dynamics, who is one of the largest engineering firms in the country. This year, most of our materials that were used for either engineering or marketing were reused from previous years, so we didn't have to spend extra money on that. One of our main goals at Archer is to learn about engineering and marketing and how to run a company in the real world. But we also want to give others an equal opportunity to learn the same thing. To do this, we held multiple events where we showed our robot and the BEST program and answered any questions we could about BEST. We had multiple open houses to show what it would be like to be in the BEST competition, and Home Depot allowed us to set up our robot in their store so we could answer any questions to shoppers passing by about BEST and about our team. This spring, we had a class for young students where we taught them about engineering and how to work different programs. The students learned how to build little miniature stoplights in which they learned to program them like actual working stoplights. This is a great way to introduce young students to the STEM program. Recently, we've been handing out flyers to give information about the BEST competition and to give a website to watch the competition live tomorrow.
Now, in order to create an award-winning robot, you must first have to have a plan in order to build and construct this robot. This plan is called the engineering design process. It starts out by defining the problem. In this case, it's driving around the field, collecting ores, and transporting ores. We solve these problems by brainstorming. Now, we had many brainstorming meetings, but the first one started on the way back from kickoff. And at first, no idea was thrown immediately, because any idea could lead to a winning solution. For example, one of these ideas is the net.
Now, on our finished robot, we can divide it up into 4 main parts. The first of these, as already mentioned, is the net. The second is the base and wheels. The third is the arm and scoop, which holds the net. And last but not least, the lifting fork. But still, the first and foremost of these parts of the robot is the net.
When we were brainstorming, we were trying to figure out what would be able to catch the coal. Not only did it have to be large enough to catch the coal, it had to be small enough to fit in the 2 feet space, it had to be versatile and lightweight. We realized that a net would meet all these requirements. We used the engineering design process to try some of our options. First, we made a nylon string net, and as you can see behind me, we used 3 types of glue: wood glue, epoxy, and PVC cement. The epoxy worked the best out of all of them, but there were still problems with the net because the holes were too big, so everything just got caught. So we made a duct tape net. This is part of the original duct tape net. But there were still problems with the net, so we put one part of it on the robot and one part of it on the arms.
The second main part of the robot is the base and wheels, which is very important, although not quite as interesting or exciting as the net. For our base, the design of it is a large rectangle of plywood that has a smaller rectangle cut out of the middle to hold the fork. Attached to this base is everything: the arms, scoop, Cortex, battery, wheels, motors, everything. So it's very important that it is strong and reliable. As for the drive wheels, we made these out of plywood as well. Now, we could have cut them out manually, just by hand, but we decided to use a milling machine to get them perfectly round. And also, so we could place the holes around the outside to hold our tread, so that it can grip the field and drive around better. This was a fairly straightforward process and went pretty quickly. The caster wheels, on the other hand, were more difficult. We tried many ideas, including slides or golf ball casters or many different sorts of solutions, but what worked best was a smooth wooden wheel in a metal bracket that can both spin normally and rotate to follow the robot's driving. We put a lot of time and effort into designing and building these casters and making them really good so that they would be reliable and efficient and they wouldn't slow down or stop the robot. The third main part of the robot is the arm and scoop. The main purpose of this is to hold the net to catch the coal, but it can also be used to scoop up the aluminum from underneath the overhang, or pick up dropped ores, or push obstacles out of the way. This arm and scoop are mostly made out of PVC for the arm, and then flattened PVC for the scoop because it is lightweight and yet flexible and strong. Now, the motor we were planning to use for this was both too fast and too weak to properly swing the arm, so we had to gear it down. We used a 6-to-1 reduction with the gears, so that is slow enough to control accurately, and strong enough to lift the arm. The fourth and final part of the robot is the lifting fork. This is very crucial because it holds the chalcopyrite bucket. With our design, every single ore we catch, the coal, aluminum, the magnetite, everything, funnels down into this bucket. So it's very important that it's dry. For the fork, as you can see, we made it mostly out of plywood and attached to a hinge at the back. Strings on the corners are attached to strings on the corners lift up and over a frame of PVC down to a winch, which is kind of hidden back there. When the winch winds, the string retracts and the fork lifts up with enough strength to lift this heavy bucket. With all four parts of the robot working well together, we had an efficient and fast and reliable robot that can score almost all the ores in very little time.
Now, to build our robot, we had access to many various advanced technologies to assist us in the process. One of our key features is the ability to mill out parts. With a milling machine, you take a two-dimensional drawing of a shape, such as a gear. This two-dimensional drawing, CAD drawing, is then inserted into various programs until converted to a format ready for the milling machine. The milling machine is basically a drill bit that is computer controlled, able to precisely cut out whatever shape we need. For gears, precision is very important that they mesh well. We could also use this for our wheels and casters to make sure that they're perfectly round and will roll well. It can also be used for motor mounts in order to make sure that our mounting holes are consistently spaced, and so all the parts of our robot are easy to repair and switch out should anything happen to them. Now, we also used 3D CAD, such as SolidWorks, to prototype various ideas for a robot and see if our design would work, how it would fit together, and what length everything should be cut to. This way, we were able to model what our robot would be like and test it before we actually had to cut any material. So we could potentially work out any obvious flaws right away. 3D modeling was also used in the designing of our booth to experiment with various layouts of table and other shelves, just to get a visual representation before we actually had to set up the booth. Now, we also have a team website with which we're able to share information about our team and Best Robotics with those around us. Where there's information about our team, our robot, as well as a page about Best Robotics, where they can read more about the program and find a link to the Best website for more information. Now, with all of these various advanced technologies at our disposal, with our structured building process, our detailed brainstorming and use of the engineering process, and our well-organized team, we can confidently say that we have a winning product that will forever revolutionize the mining industry.